In recent decades, access to electricity has become a constant element of daily life. Most households rely on centralized infrastructure, where energy is generated at large facilities and distributed through extensive grid systems. This model has remained largely unchanged, with users acting as passive consumers. Alongside this, alternative energy systems have emerged. Solar panels, wind turbines, and portable generators represent attempts to decentralize power generation. However, these systems often involve high upfront costs, technical installation requirements, or environmental dependencies. Within this broader context, there has been ongoing interest in small-scale, independent energy solutions that can be assembled and operated at the household level. The Energy Revolution system is presented as a digital package of instructional materials. It does not consist of a physical device, but rather a set of documents intended to guide the construction of a device. The package includes illustrated blueprints, schematic diagrams, and written instructions. These materials outline how to assemble a system using commonly available electronic components. The structure of the product suggests a self-guided process. Users are expected to interpret diagrams, gather materials, and assemble the system independently. Additional documents provide guidance on modifying or optimizing the setup after initial construction. The system is described as modular, meaning the same core structure can be expanded or adjusted depending on the intended scale. Use of the system begins with accessing the digital files after purchase. The user is expected to review the documentation, which includes both visual schematics and written explanations. After reviewing the material, the next step involves sourcing the listed components. These are described as standard electronic parts that can be obtained from general hardware or electronics stores. Assembly follows a step-by-step format. The process involves arranging components according to the diagrams and connecting them as specified. The estimated time for construction is several hours, depending on familiarity with basic tools. Once assembled, the system is intended to operate as a standalone unit. The user interacts with it primarily during setup, with limited ongoing intervention. Some versions of the instructions include optional adjustments or configurations, described as ways to alter the system's behavior or output. These are presented as additional steps that can be performed after the base system is operational. This type of product aligns with individuals interested in hands-on construction projects. It may appeal to those who prefer self-guided learning and are comfortable working with physical components. IT also aligns with users exploring alternatives to conventional infrastructure, particularly those interested in small-scale systems that can be assembled independently. Because the product relies on interpretation of diagrams and manual assembly, it assumes a certain level of patience and willingness to follow procedural steps. IT does not require formal certification or professional training, but it does require time investment and attention to detail during the build process. Compared to conventional energy systems, this product occupies a different category. It is not a utility service, nor a ready-to-use device. Instead, it functions as a set of instructions. When compared to commercial alternatives like solar panel systems, the key distinction lies in format and accessibility. Traditional systems are typically installed by professionals and involve regulatory considerations. In contrast, this system is positioned as a self-assembled solution. It also differs from portable generators, which are manufactured products with predefined specifications. Here, the user is responsible for constructing the system from the ground up. In the broader landscape of DIY electronics, the product resembles instructional kits or technical manuals that guide users through building functional devices. The effectiveness of such systems depends on the accuracy of the instructions, the quality of materials used, and the precision of the assembly process. For those interested in examining the structure and documentation behind this system, the instructional materials referenced in this video are available in the description.